All right, Alex, 5-second warning.
Good evening. I'm Alex Moore. I'm a fellow of the Explorers Club and an associate professor of public health and environmental health at Long Island University, Climate Change Institute, University of Maine, and a research associate at Harvard University, where I study the impact of climate on pandemics and the impact of people on climate. Tonight, we are going to talk about the cutting edge discoveries of the past year that have allowed us to weather the storm of COVID-19, the pandemic, and start thinking about scenarios where the virus may be controlled. The speed and complexity of the new life-saving science being implemented in public health measures throughout the world, in the country, and in our own city is unmatched in human history. However, the speed of new variants emerging throughout the world is making this a race against time. And this is what we'll be talking about today. To introduce our speaker for tonight, we have our member, his daughter, Mayor Haseltine, international artist, a pioneer in the field of sci-art, and environmental activist and educator. She collaborates with scientists and engineers to create work that addresses the link between our cultural and biological evolution. Last year, her work, Radiolarian Skeleton, became part of the permanent collection of the Explorers Club. And this year, she's establishing an NGO entitled the Geotherapy Institute for Art and Field Science. Here's Mara Haseltine.
Thank you, Alex. Thanks for the beautiful introduction. I'm so happy to be here tonight. And I also just want to give Ann Passer a huge shout out for this past year of incredible programming and keeping us all together around this virtual hearth of knowledge and connection. I really want to take a moment or two to actually thank my father for coming here tonight. He has been, well, he's my father and my mentor, my scientific advisor throughout my entire life. His curious encyclopedic brain has really driven me towards the pursuit of primary source material, which is what I base my practice and teaching philosophy on. In fact, he has been an incredible defender of primary source material and science in this past crazy year, where actually absolute truths and primary source material has been under scrutiny. And for that, I think I would like to thank him on behalf of the American and the global public at large. He has been in a lifelong quest and a fight against disease, and I have been privileged to watch this. This has been maybe his 4th or 5th time being recognized globally. And I think actually it's my favorite moment of his in the public realm. He has just been in everyone's living rooms, calming them down, speaking the truth. And so I am so excited to introduce him to Alex Moore tonight. I've been a fan of Alex's for a very long time. And I guess in lieu of giving him an award for his work, I'm giving him Alex, this amazing brain who's thought about the pandemic and also has this way of thinking about disease and viral health in a planetary way, dynastically, which is something that I think we really need to do in our push towards well, my push is towards a global bioethic, which I think many people at the Explorers Club would also endorse based on truth. So without further ado, I give you Dr. William Haseltine.
Thank you, Mara, and thank you, Alex, and thanks to the Explorers Club. I'd first like to say it's been a privilege to get to know about the Explorers Club through my daughter, Mara. She's been a member for some time. She's had a number of presentations there. You can see just above her head this thing that looks like a virus, but actually it's not. It's maybe the first piece of contemporary art to be housed in the collection of the Explorers Club. But the Explorers Club is just a wonderful place. And every time I go there, I'm exhilarated by the human spirit's curiosity to know what our planet is, and more than that, to do something about it. And so it's a great honor and a privilege to speak here, and also to have as the interlocutor Alex, who's a wonderful thinker about disease and our planet. And we expect a lot from him and more of these discussions. So it's a great pleasure to be here tonight. We're at a very awkward moment in the pandemic. It started well over a year ago now. It's a moment where we can look around the globe and see the devastation that this virus is wreaking, particularly in South America and in South Asia, particularly India and Bangladesh, where there is now something that we have always feared might happen, but a tremendous exponential rise that daily gets worse. And the nature of exponentials, as you know, is the next day is far worse than the previous day. And that's clearly happening not only in South Asia, but a couple of other places around the world, and showing the true power of a pandemic unleashed on a sensitive population. But it's also a moment where we can stand from where we are and begin to see an end to this pandemic. And that's what I'd like to talk about tonight. What it is that we can see, as far as we can see into the future, of an end to the devastating effects of the pandemic. Now, right from the very beginning, I'd like to say that an end doesn't mean that COVID disappears from our world. It means that it disappears as a determining factor for how we live our lives. I know that many of you, like myself and my family, have our lives really transformed in ways we just didn't expect by this pandemic. My life is extremely different from what it was this time even a year ago, and certainly 18 months ago. And I'm sure that's true for most of you. I have lost friends, as you have probably lost friends. A lot of family members affected in one way or another, some directly by the infection. And so it's a very sober time, but it is a time when we can look forward to seeing perhaps an end. But before I get to why I see that, and I'm sure there'll be questions about that, I'd like to talk about the very nature of what we're experiencing. And I know that this is something that Alex thinks about very deeply and has for a long time. That is, what is our relationship to the natural world and to the world of viruses? And what's changed? Well, in the last 20 years, we've seen three major infections from virtually the same source: bats. Bats and coronaviruses have entered our population in new ways in three different times. This, of course, is by far the most devastating, but it's not the first or the second, it's the third. The first was SARS. SARS emerged from bats into people. It spread very widely, but the characteristics were different from this one. If you got it, you got sick very quickly, and 1 out of 10 people died. That very nature allowed us to understand it, to control it, and eventually eliminate it from the population, not with medicine, but just very strict public health measures, identifying those who were sick, who self-identified when they were sick, and before they could really transmit it very much to others. The second was that bat cave, that virus emerged from a cave in Southeast Asia, and in South China, as a matter of fact. And the next infection was MERS. That actually came from bats from Egypt into camels, from camels that were exported into the Middle East that then got into camel handlers. And today it still exists. It's far more lethal than even SARS. Kills about 1 out of 3 people it infects. But fortunately, it doesn't infect very often, and it's not easily transmitted. But for this virus, this family of virus, the third time seems to have been its charm. And what it has done from the virus point of view is something that is pretty amazing. It infects people, but the vast majority of people either don't know they have it or have a very mild code. And for a period of time, they can transmit the virus before they even know it, they've had it. And that is by far its most dangerous aspect, because it can spread unbeknownst amongst large populations. About 80% of people who get the first strain of the virus have either no symptom or very mild symptoms. About 20% of people have more serious symptoms. And in most populations, about 1 out of 200 people die. It can be a little more, being a little less, depending on the age of infection. That's the first way the virus showed itself and spread around the world. Now, why is it? And it's a question that I think we're going to be asking for a long time. Why is it 3 of these have come out in just the last 20 years? One common thought is that humans are encroaching on the natural environment. And when you do that, you disturb natural ecosystems. The viruses that are there come out and they get into people and they spread. That is certainly part of the story, but I don't think it's a major driver. I think the major driver of this and other pandemics that we've had and will have is because we've created a new ecological niche. We humans, we are different from what we were even when I was born. There are about 5 times as many of us, about going on 8 billion people. And there were only a quarter of that number, more or less, when I was born. We are highly urbanized. Again, we've undergone, just in my lifetime, a transition from 20% to about 80% urban environment, people living in cities. That means they're close packed, perfect for spreading viruses. We know that we have around the world, in our own country and many other countries, marginalized populations or large parts of populations that are poor and live in very packed conditions. And there's one other condition that is different from what it was before, and that is in 2019, 4.5 billion people hopped on airplanes and traveled from one place to another, very often across the globe. That is a new ecosystem. And viruses are always on the lookout, like any organism is on the lookout for a fertile place in which to grow. And we've created a marvelous environment for this virus and for others to come. And that's one of the first messages. We have to be more careful than we've ever been before, because we are a very attractive target. Now, what are these viruses? Well, one definition that I read not long ago is a virus is trouble packaged in a protein. But it's more than that. A virus, in my sense, is alive because it meets many of the criteria for a living system. Yes, you can synthesize it from raw chemicals. You can crystallize it. It requires another living organism to live, but so do we. We require a whole ecosystem for us to live. Whereas a virus just requires cells, either a single cell or an organism, but we're all dependent, interdependent on a whole ecosystem. And we happen to be a good ecosystem for viruses. We're not the only one. We create large herds of animals to support ourselves, and they're also good ecosystems. And we create huge numbers of crops, which are ecosystems for other kinds of viruses. But what a virus is, I think we now have a language for evolution and for viruses that we didn't have before. It's an intelligent machine, not that it has a purpose. It's not purposeful intelligence, but it solves complex problems by random mutation. And the mutations that this virus I've calculated have gone through so far are either 10 to the 20th or 10 to the 21st. That's a huge number, one with 20 or 21 zeros after it. That's a lot of experimentation. It can happen very fast. And so the virus is continually changing. The more people it affects, the more opportunities it has to change. And so that's the fundamental dynamic. It's a machine intelligence trying to crack the code of this new ecosystem. Now, what is that code? Our code is our immune system. We try to protect ourselves naturally from the immune system. So we have our own variation that goes on with our T cells, our B cells, our antibodies, And our evolution, our natural evolution, is trying to keep pace with the virus. But we'll never win that race. That virus can mutate much faster than we can cope with it. We can control it, the original one, but as we try to control it through our natural immune system, it keeps changing and trying to solve that. And that's what we're seeing in India today. At first, it looked like the immune system of human beings could more or less control it. But then the virus changed and now it's out of control. And it's learned how to, through random mutation, crack the biological code. But it's cracked a lot of other codes too. It's cracked our social code, so we live together. We're very gregarious. We love to be together. Just walk through any street in any city and you see people close to each other, chatting, talking. This virus is airborne. We know it can live in the air in tiny particles floating around for days. A new fact, which is unfortunate, but actually it turns out to be a fact, is it doesn't matter if you're inside a closed space, if you're 60 feet away or 6 feet away. The air still circulates. As far as that air circulates to where you are, you have a chance of getting the virus. In its first incarnation, it was pretty infectious. But now in its second, third, or fourth incarnation, it's much more infectious, which means it takes many fewer particles to infect you. So you could, maybe a year ago, be in a room where somebody was infected and not get infected. That's very unlikely now. It could be in the past that one member of a family would get infected, but the others wouldn't. That's in the past. Now, if one member is infected, almost everybody is surely to be infected because it's more infectious and it goes through the air. And so that's what's happening to us. But there's another code it's cracking. It's cracking our sociopolitical code. What do I mean by that? Well, we humans can adapt our behavior to stop the transmission. And there are great examples of that. China has been by far the best, 1.4 billion people with virtually no COVID. Why? Because people have adapted their behavior in such a way as to limit the virus. But unfortunately, even though it is possible in certain settings, Australia, New Zealand, Taiwan, Bhutan, Andorra, but most particularly China, human beings have learned how to change their behavior to control this virus. We've outwitted it in some parts, but most of the world, the virus has cracked the socio-political code that people aren't willing to change their behavior rapidly enough or systematically enough to control it. And the virus has taken great advantage of that. Certainly in America, it's done that. All throughout Europe, it's done that. South America and India, it's done it in force. Philippines, it's the same sort of picture. Even in Japan, which you would expect, because it's an Asian country, might have had more discipline. It's rampant in Japan today. So the virus is a code cracker through its own machine intelligence. Now, what do we have that's opposed to that? Well, we have, as I mentioned, our immune systems, which throw random combinations at the virus. In some cases are successful. And the virus then changes itself to adapt to that. But we have something else. Nature has endowed us through an evolutionary process with the ability to adapt, not evolutionarily from generation to generation, which really would take 5 generations, 6 generations to do, which we've seen, for example, viruses being introduced into Australia to kill rabbits. It takes about 5 generations for those rabbits to get immune. In the meantime, about 95% die. That can happen. But we have something else. We have intentional intelligence. And that's an evolutionary adaptation to allow us to change our environment in our favor through intention, not through random selection. That is a huge advantage. That's why we are so numerous. It's our selective advantage on this planet. Now, it might not be completely healthy for the planet. One thing the Explorers Club certainly knows for sure, and Alex studies, but it is what we do. And we can use that intelligence in a couple of ways. So the first thing that I would say when we look at an end to COVID is it's been ended in China, in Australia, in New Zealand, and a few other countries. through intentional intelligence. They've modified their behavior. What do? They identify people who are infected. They contact trace. They isolate everyone who's been exposed and who's sick. And they don't release them from isolation, so they don't meet other people until they no longer have the virus. And once they've done that, they make sure anybody comes into their country is free of the virus. And if they're not free of the virus, they're isolated for a long time. And if perchance there is a local infection, they put a huge machine in place to test millions of people to see who's infected, isolate, contact trace, isolate until they no longer are infected. I might say there's some aspect of this infection that most people don't pay attention to. And that is, I've come to realize it's as much an intestinal gut disease as it is a lung disease, at least as far as transmission goes. And that is, after you've cleared the virus from your nasopharynx, where everybody tests for it, you still shed it through your intestine. It's a oral fecal route, and it's a fecal aerosol route. And the Chinese understood that right away. And when you were isolated, you had to disinfect your urine and your feces because they could see that that was a form of transmission. And it's transmitted for a longer time, on average, through the fecal route than it is through the aerosol route. And that's something that we in Europe, United States, in South America, don't even talk about. But it's something that the Chinese recognized very early on. I have a friend who was on a plane where somebody was infected. He was isolated and with his wife in separate rooms for 2 weeks, and they were required to disinfect their feces and their urine every time they had to use the bathroom. They had to disinfect their feces and their urine. It's something we should do as well. So we can control it intentionally. That's the good news. But because of our sociopolitical belief, organization, I would even say there's a fourth way it cracks our code. It cracks a belief code. There's belief that your own personal freedom, your own ability, whether to wear a mask, to isolate yourself, is predominant over your social responsibility. That is what we see in most of the world. So this virus has cracked that too. That's why India is rampant, United States, it's still infecting 60,000 people a day. Something I say to people is, if you really want to have a picture for what's going on, imagine everybody fills up a stadium in the United States every day with 60, 70,000 people. And as they exit the stadium every day, there's 1,000 hearses lined up. If that were the reality, which is our reality in this country, but if we actually saw it visibly, all those hearses, and we know that 60,000 people will go into the stadium, but not all would come out, we'd behave differently. But somehow we don't understand it that way. And the viruses, through its machine intelligence, has understood that. So the first thing is, and as a scientist, and I have to say with HIV, it was pretty much the same thing. We knew how it was transmitted. We knew we could modify behavior, whether it's HIV and modifying sexual behavior or modifying social behavior, could control it, but we don't. So then we do our next fallback. Our next fallback is saying, well, let science save us. Well, science has not yet saved the world from AIDS, but it certainly controlled it. You know, if we hadn't had a way of understanding its transmission and creating combinations of drugs, the death toll would be many times the 35 million that have died from HIV in the last 35 years or 40 years, be far greater than that. But we have learned something about how to control it with our science. So now what is our science doing? Well, let's talk about vaccines. Vaccines are one of our great inventions. They go way back, actually. When you actually look at in depth how far back our knowledge of vaccines goes, it goes back really about to the year 600, where the Chinese began to do something called insufflation, where they take scabs from people who had smallpox and actually blew the powder from those scabs into people's nose. Sometimes they died, not often, but they would get infected and they would be resistant forever. And then, of course, we know the stories that come from then the next iteration of that was from Turkey, where they did it. That knowledge came into the US, came into England and the Western Europe. And later, that knowledge got reflected in understanding that a cowpox would give you a much more mild form. Most people don't realize in the United States, we didn't use cowpox early on. There were patents on that. We broke those patents by using deer pox. They stood right behind the house of Mr. Waterhouse. In fact, it was Waterhouse Street on Cambridge Common. My house was directly adjacent to his former house, and he's the one who introduced deer pox vaccinations into the United States that were able to be very successful. So we have a long history of vaccines. And I have to say that the rapid development of our vaccines for COVID has been nothing short of remarkable. The Chinese determined the total sequence of the SARS virus. The virus identified the virus, sequenced it, made that publicly available in early February, and all the companies, many companies got right to work. And we have some of the best vaccines, and in fact, maybe the best vaccines we have ever had. The mRNA technologies are a marvel. People who can be protected by this, and the mRNA vaccines are at least shortly after 2 vaccinations are 95% infected, protected. That protection is probably going to last 6 to 9 months at least. With virtually no side effects. Nothing is without side effects. But those mRNA vaccines are totally amazing. The other vaccines, the adenovirus vectored vaccines, the killed proteins, the killed virus, are somewhat effective, but nothing like the mRNA vaccines. We lucked out with the right technology and the right virus, because that same technology doesn't work for all viruses. It's been tried for a lot of other diseases. It's effective, but nothing like 95% effective. So that is the great news. Now, can we, as a species, get that vaccine all over the world? You know, one of the things I realized, being a scientist and developing drugs, first of all, doing the fundamental science, then working on ways to apply that, creating companies to create new medicines, I realized that there's a huge problem in the world, as everybody knows, and even in my own country, that the great advances of modern medicine are not equally accessible and affordable to most people in the world. That's not a question that they don't work. It's a question of social organization. And more than that, it's a question of political will and policy. That's what we need for protection of the world. And that's why for the past 15 years, I've been working on exactly that problem. I'm an advisor to many governments. My foundation works in many countries. We have a slightly different model. We only work with indigenous people, people who are from that country, organize and understand the nature of their governments. Some places we've been very successful in influence, like India, to help write some of their health policies where they're early stages of making major transformations in health systems delivery. So we have solutions, but the question is, can we get them to the whole world? I think the answer is yes. We as a world have done it for polio, almost eradicated it. We've eradicated smallpox, and we've eradicated an animal disease called rinderpest. And we have a chance, maybe not to eradicate this, but to control it through vaccines. We are now in what I call generation 1 vaccines, very specific for the first 2 strains that emerged. And they're very effective. But they're not effective against all the strains. For example, the AstraZeneca vaccine is only 10% effective against some of the variants in South Africa and some of the ones that are here in this country too. Fortunately, right after, at the peak of their effectiveness, the mRNA vaccines are more effective. But what we know about these vaccines is they wane in strength over time. And it's more difficult to re-immunize people against the next variants that come out. So what is this virus actually doing? As it encounters people with immune systems and in people who have been partially protected by their own immunity, but not fully, what the virus does is mutate. And that's what it's always doing. As I said, it's 10 to the 20, 10 to the 21st. And it's cracking our ability to make the first generations effective for all variants. We know that because people in India and Brazil and many other countries are being reinfected. And even we know that some people, the ones where the vaccines are failing, is about 10-1 in favor of a variant over the earlier versions. So these viruses are cracking the code, not completely. We have some protection from the current vaccines, but not total. So now there's second generation vaccines. Think of them as the flu vaccine. Flu is doing exactly what COVID does, except I would say not even except, it's very similar to what it's doing. So every year, in fact, because the population's more naive, it's infecting us pretty rapidly and it's changing very quickly. And so the second generations are going to be directed against some of the variants, and they are going to be effective at those variants, but then there'll be still new variants. So now we're looking for, and that's what's going to happen. So when you hear people say you're going to be inoculated maybe every year or maybe every 6 months, that's what they're talking about. And that will partially control it, but the virus will still keep changing. Now, only recently, very recently, there is some hope even on that front. And my hope is that the solution to this problem will also help us solve a much older problem, which is the flu problem. And that is creating vaccines that recognize the virus Achilles heel. Now, the viruses are really clever. We've studied AIDS for a long, long time. It gets into your body, it lives with you for the rest of your life. And every day your body has to fight it. And the virus has to change in such a way so it can cope with the immune system every single day. Well, this virus doesn't have to be that clever. It only has to really do what flu does, is crack a code every 6 months, every year. So it's not as evolved to evade our immune techniques as is HIV. And so there are ways that we can try to create vaccines that are very broad. And there's hope on that scene. I've looked at a number of different examples. In fact, I just wrote a piece today on what I call the appearance of the Achilles heel of this virus. I think there are going to be ways to get at things this virus doesn't like to change. That wasn't possible for HIV, and if somebody's interested, I can go into considerably more detail. You would probably want to hear about exactly how that's going to happen, but suffice it to say, I think a year or two from now, we're going to have vaccines that are protective against most strains. So that's the first good news. That's why I see, standing from where we sit today, or where we stand today, we can look forward to see a time where, at least in countries where the vaccine is available, these new third generation vaccines are going to be very powerful tools. That's us adapting to it, not through social measures, but through medical measures. But there again, we need social and political cohesion and coherence. We have to, because as long as this virus is infecting some people somewhere, we're at risk. We in the United States, we in any country. Just look at China today. They take extraordinary measures to make sure that people who come into their country are free and aren't going to be focused for infections. Same in New Zealand, same in Australia. If we're fortunate enough to stamp out most of the infections here, we'll always be on the alert, and it will change the way we live. If we don't keep the virus out of our country, or much more preferably, to use our techniques to stop it worldwide. And that's going to take an effort much bigger, I have to say, than the effort of smallpox or even polio, because they didn't change as much as this virus changes. There's another avenue of approach, which is now coming into view. And that is the use of drugs, pills that are prophylactic. That is, think of your travel to a malaria zone. And I don't want to mix this up with hydroxychloroquine, but when you go into a malaria zone, some people take pills that help fight off malaria before they even get it, a prophylactic drug. And HIV is now in a position where people are getting very good prophylactic drugs. Now, HIV is difficult from a drug point of view, because you've got to take the drug for a lifetime. Here, you only have to take it after you've been exposed, or when you're likely to be exposed. And I can tell you from looking at the literature there are many drugs in the pipeline, and some of those drugs, I'm convinced, will be powerful drugs, orally available or through a simple intramuscular injection, which will protect you from infection if you are exposed, or even if you have a chance to be exposed. And we know that that approach is working because we've seen it work in congregate living situations where people are packed together, somebody's infected, and the rest just don't get infected. That is really good news. And it's a tribute to all the work that's been done on other viruses and particularly on HIV, because almost all these researchers that created these vaccines and that have created these, or are creating these new drugs, are former HIV researchers. And the government mechanisms that we use to test them are also derived globally from our HIV work. And something that I'd like to say about our own country is that most people don't realize the United States has spent over $100 billion treating people in Africa for HIV. The United States has had a huge role in controlling HIV in Africa. It started under President George W. Bush, and it's continued even through the last administration, where we provide the infrastructure, the drugs in countries, and we even provide the medical technologies and the people to make sure that everybody in remote villages. I've been in parts of Africa. My wife and I have traveled extensively in Africa, where there's a single hut. It takes 3 hours to get to, yet they get their HIV medications. The world can do this with drugs and with the vaccines. Now, one other thing that we can do very well, but we haven't done particularly well up to now, is surveillance. We've got to know what's out there, what's coming at us. We know how to do it, but we're not doing it systematically. Fortunately, we've just committed $1.7 billion to create a surveillance network to know what's out there and to have the information systems within our own country to correlate the virus we see with the disease on the ground and the transmissions that we see. That is coming within the next year. That has to be a global effort. And I believe it will be and can be a global effort. There's a fundamental reason for that. And it isn't just health. It's that this virus is an economy killer. And an economy damages the life of everybody in a country or the whole world, not just the people who are infected. Yes, people care about human life, but politicians care about economies more, I would say, most politicians, than they care about human life. And this has got attention in a way that is, I'd say, phenomenal and beneficial from our point of view. And let's hope it continues. And I'm pretty sure that it will. So I think all those things together provide hope that science will save us if our belief system doesn't allow it to. Now, we do have problems. There are people in our own country and around the world that won't take vaccines, at least right now. There's going to be a huge debate. Right now, we're right on the brink of vaccinating all those who want to be vaccinated. Will that be enough? Most people say no. We may have to do more to help people understand that their life, their children's life, their economic life is dependent upon the use of these powerful scientific tools. I think we will prevail both in America and around the world. So I'm actually in the long run optimistic, but I'm not optimistic in the very short run, being the next few months, even the next year. It's going to take a global effort, 3 to 4, maybe 5 years before we're really out of the woods from this virus. And only if we are committed to use our powers of rational, intentional adaptation to cope with this new natural disaster, and to realize that we are now the target for many more, and use the techniques that we're developing to understand what's happening and to mobilize rapidly so that the next pandemic doesn't get the foothold that this one does. And with that, I am happy to answer questions. I know Alex is going to start with a few questions, and happy to take many more.
Thank you so much, Dr. Haseltine. That was really illuminating. There are several questions that have been pouring in, and I'll try to address all of them, all the ones from our audience. But I'd like to start with a few of my own. One in particular is the explanation, a better explanation of what variants are and how the virus really behaves. In media and elsewhere, we get these celebrity strains that everybody talks about for a few media cycles, and then they disappear. Now the very erroneously called double mutant, as if there were only one mutation strain in India. So can you explain to us better perhaps how that random mutation occurs and how it is a race against it when we use machine learning and new tools to adapt and find better vaccines to address it? And while you're there, why don't you also tell us how that mutation increases exponentially the more people actually get the virus and become infected?
Well, I've, as you know, Alex, I've looked at this variation. I've written a book called Variance, a shape-shifting challenge of COVID-19. I've got a new way of actually communicating through what I call a living ebook. So although I've written the first book in January, the second version has come out in early March to bring us up to speed. And the new version is going to come out in a week or two. And if you buy one version, you get all versions. You get a code and lets you get all the other ones.
As you know, I double as your book agent.
Thank you. Thank you very much. So it's the issues that you've asked is, what does a virus do? Let's just, from the virus point of view, think of yourself as a virus. Your job is to get from one person to another and to get from that person to yet another. So let's take it through the steps. The first step is it's got to get out of your body. Well, it gets out with your breath, and it gets in these fine aerosol particles, and it gets out through your feces. It gets out through your urine. It's also sexually transmitted. So it's got a lot of different routes. For example, a lot of people, 30 million people, just jumped into the rivers, the same river in India, and they were sharing the water, and there was certainly some fecal material. There was urine in there. There were live viruses in there. Those would get into their eyes, their nose, their mouth, or you have the receptors, or you can breathe it in while you're in the midst of those crowds. So that's how viruses have got to get out. So it's got to have a way of surviving when it's in the air. And some of these variants, it hasn't been shown yet, but I'm sure you're going to find it, are more air stable. That's one thing it can do. It can change because this virus is a particle. And it can change its properties, so it's more resistant and can live longer outside of the body. Then it's got to attach to something. To get into your body, it's got to have a structure, which is a lock and key fit at the atomic level. Each atom has to match very precisely to a structure. Now, the structure that is used is called the ACE2. You use it to help protect yourself. If you're a smoker, it helps protect you from smoking in your lungs and your nasal pharynx, and that's how it gets in. It grabs a hold. Now, it turns out that those receptors in the nasopharynx are about, if on a scale of 1 to 10, they're about, the density is about 2, whereas in your intestine is about 10. And in your blood vessels, it might be 3 or 4. You have those receptors all over your body. So once the virus grabs a hold and starts growing in you, it's got a lot of different places it can go. It can go to your heart, go to the lining of your blood vessels. It can go to your kidney. It can go to your pancreas. Can get a lot of places in your body. Next thing it has to do, it's got to enter the cell. And so one of the things that happens with these variants is they make it possible to attach more tightly. So you don't need as many receptors. One of the reasons children are less likely to be infected is they have fewer receptors. But with these new viruses that can attach more tightly, it's infecting children at a higher rate. So more stable, attaches tighter, and then enters more efficiently. All of those things we can see in the mutations, the changes in the text of the virus. It's changing the structure so it actually sticks tighter. It's changing the structure so it enters more readily. And then there's a series of things this virus does. When it gets in, it actually, with its own proteins, reprograms your cell to create a small compartment that shields it from anything the cell can see and produces its own copies of its structures. That itself is a protective form. And some of these mutants increase the efficiency and tightness of that package. And it has another whole set of genes, at least 10 that I've counted so far, that modify your ability to recognize it. I'm not talking about not recognize it. They interfere. In fact, there's a famous molecule called interferon. Think of that as an alarm system that has to go off to get your immune system to react. This virus breaks the alarm system. And it doesn't just break the primary alarm system. That alarm system works by sending a signal, and it turns off those signals as well. So it gets a free ride for a while, and it gets better at that. We can see changes in this virus that get better. Well, how does that translate? That means instead of being infectious for 1 week, people infected with these variants are infected for 2 weeks. That's good for the virus for getting around. Now, the other thing it can do is make more of itself. The more it gets squeezed by your immune system or other pressures, the more it tries to compensate by those variants, those random mutations that allow it to replicate to higher concentrations. So these new variants produce more virus per cell and more virus per person, which means more virus can get out. That's a short history of what's going on. And it's going on pretty fast. And it's not just one line. You pointed out there's a variant du jour or du week. That's not what's going on. It's changing all over the place. We see variants of variants of variants at this point, third or fourth generations. Actually, the first variant happened in February, almost unknown, unnoticed, except by a few Chinese who saw it early, very early, pointed it out. People ignored it. It was pointed out again by a group of scientists very vociferously from their point of view, but nobody heard that either. Spread all over the world, that particular virus. You have to think of it as like any kind of evolution where something that's more successful outcompetes all the others and the others disappear. So the first virus from Wuhan, you don't see it anymore. All you see are variants. And that variant took over almost all the world, not quite. Not in Tanzania, where it produced its own variants from the original Wuhan virus. And if that weren't enough, if two of these get into the same person, they can recombine and make something that's even more successful. And that's going on at an enormous rate. Now, the second part of your question is, why does it matter how many people are infected? Because it's just a simple matter of math. If you have one person infected, it can make a certain number of variants. 10 people, 10 times as many. Now there's 100 million going on 200 million people. So it's whatever number of variants you could get from one person, you can get 200 million times as many variants now. And that's why it really matters how many people are infected. That's why what's going on in India now is so deadly dangerous, because I guarantee you it's filled with variants that we haven't even seen yet. And that's happening in Brazil, in South America, in everywhere this virus goes. And so I think that's at least that is some explanation and answer to your question, I hope.
No, definitely. And that it was also a loaded question because as some of the questions that our audience sent in, there are calls to change our habits, to relax our guard. And in fact, the more people relax their guard, the more variants we're going to get in the end, which is what you just described. I wanted to discuss for a second, there was a question about the transmissibility, the fact that that animals can also be infected. We saw the minks in Denmark being infected and actually mutating the virus at some point. And one of our audience members was asking whether the strains that have been detected in animals are the same as in humans. Another question I wanted to add to that is what can we do to monitor the environment better? You know that this is some of my research as well, but I really would enjoy your opinion on this, especially to prevent the next pandemic.
Well, let me take one step back from that. Why is it that many of our most dangerous viruses come from bats and birds? Well, what do they do in common? They fly. We don't fly. So how come they get us? And how come they can live in those animals, but they kill us? And the answer, I think, has to do with a field I worked in many, many years ago called DNA damage and its repair. And one thing you realize, and one thing that is any living system, is that basically we're a slow fire. We breathe in oxygen and breathe out carbon dioxide. That's what a fire does. You consume carbon and you release energy. We eat our food and essentially we're burning it, but we burn it in a very controlled way. That's how we get our energy. We take in the oxygen, combine it with carbon, but it doesn't get super hot. We have ways of controlling it, but we're not perfect. The damage that is done by what's called superoxides, or forms of oxygen that are highly reactive and just bust up DNA and other cellular components. And if you look at a mouse, he burns himself up in 2 years. We burn ourselves up in 100 years. Some sharks don't burn themselves up for 400 years, or trees might be 2,000, 3,000 years, but eventually we do. But in order to protect ourselves from that, we have a whole bunch of ways to scope up free radicals. And that's our protection. And we're, a lot better than a mouse, but not as good as a shark or a tree. But we do it pretty well. But a bird or a flying animal uses enormous amounts of energy and is creating all these superoxides and these radicals. And so they would normally inflame that animal. It would basically feel like you'd done a massive workout 24 hours a day. That's what your body would feel like. It would be, you destroy your body. So they have much better ways of controlling that inflammatory damage that the oxygen radicals do. And so when the virus gets into them, they can tolerate it. It gets into us, we can't, because as we know, what's killing a lot of people are these inflammatory reactions that cause all sorts of trouble in our lungs, in our blood system, et cetera. So that's basically the equation. Now that maybe isn't where you were headed, but that's, I think, important for people to realize why the flying species are more dangerous from us than others. Now, the other thing that happens with this virus is we share these receptors, ACE2 receptors, with many, many mammals. But not all of those mammals, the ACE2 receptor is the right lock and key. So far, about 80 of them have been found that are. Those include our dogs and our cats. They include all other primates, or most other primates that I know of. They now, thanks to the variants, include mice, which they didn't before. The virus variant attached to us better, and attaching to us better infected our mice. Now, can those bounce back and get us? Yes, they can and they will. Same with flu. Where does flu come from? It comes from birds. Sometimes it comes from pigs and birds combined. That's where it comes from. And so we've created not just an infection in our ecosystem, we've created a new infection in all our surrounding ecosystems. Every animal that can be infected because they're in contact with us, I guarantee you will be infected. Look at the zoos. The primates are infected, the big cats are infected. That's just because we're in contact with them. Wherever we are, there's so much virus around. We're spreading it in our environment and it's going to come bouncing right back. Will it come bouncing back in the same form? No, it'll go through its own evolution there and come and get us. I have friends who have dogs who got really sick. I read a little piece about this, as a matter of fact. The new variants give dogs heart infections. The old ones didn't. The new ones do. So vets are seeing a whole flood of dogs with heart failure, which they had never seen before. Are those viruses eventually going to come back and get us? Yes, they will. So it's not just a question of monitoring our human environment. As you well know, it's modifying our entire ecosystem with its new sets of viruses, not to mention other ones that are lurking to come to get us again, which, as we pointed out, in the last 20 years have happened. Actually, if you really look at it, it's happened about 12 times from different viruses. Not quite as bad as this one, but somewhere in the world, there's been an encroachment into this brand new ecosystem. And sure as we're sitting here, I can tell you, when you look at the war games or you look at the projections of people who've studied this in detail, so where the next pandemic will come from, they did not predict it would be a coronavirus. They predicted it would be a paramyxovirus or a rhinovirus or a picornavirus, another cold-causing viruses. They're out there and they're going to adapt and they will get us. And I think your point, you've got to have surveillance for what's there. But the most important surveillance, because you can't predict which animal is going to do it, is what is happening in the human population and to react very quickly. We have the technologies. I hope we have learned that we've got to use them.
So
this is not new to this community. I've been warning since 1985 when AIDS came, and many of my friends and collaborators have been warning this. They warned in 85, in 90, in 95, in 2000. Famously, Bill Gates warned in 2015 this would happen, and now it's happened.
Well, I mean, we have been very lucky to go a century without a pandemic of this size. So it's anyone who's read history.
Don't forget HIV, 35 million dead.
Exactly.
75 million people infected.
So there are a lot of questions, and I'm going to try to bring a few together, following what you just said, and regarding the environment and new vectors, that is carriers, animal carriers of the disease, and how we can have zoonosis, that is the disease bouncing back at us. One of the other questions is how seasonality changes in the seasons can affect the infection rate. And I remember one of the first articles on this was in March 2020 by Kistler et al. At Harvard, and they predicted a flu-like up and down infection rate that went with seasons. Do you expect that? And in order to monitor that, would you go as far as, for example, monitoring sewer systems, as some universities in the city, I'm not going to mention who, did last semester?
Right. Well, let's talk about seasonality first. Very early on, I recognized that this virus was like flu and would come back again. And at best, herd immunity would be seasonal herd immunity. And vaccines would be seasonal vaccines. I didn't yet have the appreciation that our technology would allow us to make what I think are pan-class vaccines, which I think we may be able to do now. We haven't yet done it, but there's hope on the horizon. But this virus has defied that expectation in the fact that if you look around the world today, it certainly is not winter in India. I checked the temperatures yesterday, 96 degrees in Calcutta, 93 degrees in Delhi. It's hot as heck. And it's humid in other places. So it can be dry, it can be hot. We knew that early on when we saw these waves of infection in Southeast Asia during a time when it was really hot. So there are two reasons for that. Maybe this isn't going to be seasonal. It's just much more infectious. And I think that's likely. It's probably about 10 times as infectious as the flu. Or that the population is naive and it's going to take a while for the virus to settle into the same pattern that other coronaviruses do, flu viruses do, where people congregate, where it's not a matter of the temperature outside. It's a matter of when people congregate. Because if you want to look at where flu peaks and respiratory diseases peak in the tropics, they peak when it rains, when people have to stay inside. That's when it peaks. So it's a matter of human behavior and congregation, how often one person who's infected meets one or more people who aren't infected. We can modify that, we hope, with a vaccine. So whether this is going to be seasonal, I don't know. Whether it's going to come back at us from our animals, I'm pretty sure it will, and we're going to have to be aware of that. And are there other viruses out there lurking that are coming to get us? Sure as we're sitting here talking, there are. And it's absolutely predictable that will happen because we are such a fat, juicy target.
So I'm going to try and address some of the other questions.
I wanted to say one thing to everybody
Sure.
before we end. And I don't know when you're going to end it, but we've gone an hour now. And that is, I'm an optimistic person by nature. I believe that we in our human intelligence, and we don't learn the first time, the second time, the third time, the fourth time, the fifth time, eventually we will learn. And we have such powerful tools. You know, I was reading a paper the other day, just 3 nights ago. It was almost a religious experience because of the beauty and speed and precision of the work that we're now capable of doing. We are a marvelous species. We have enormous powers of reasoning. We can understand nature in ways that, you know, when I was working on AIDS, we were very pleased we had the tools we had. We're doing 100 times faster and better and deeper. The work we're doing is, you know, it's as if there are Rembrandts popping up all over. There are beautiful minds working with fantastic tools. We should be proud of our species when we do what we do at our best. We should despair that we're all not logical as Mr. Spock should be. Okay, we're sort of a mixture. But eventually, as I said, the title of this talk is An End to COVID. We will see an end one way or another, hopefully sooner than later. Because as Camus said at the end of his book called The Plague, there is much more in the time of plague. There is much more to admire in the humankind than there is to despise. There is something to despise, but there's much more to admire.
That's wonderful. A wonderful note to bring in. I do have a ton of questions, so if you can hold on a few,
Sure.
perhaps we can give some more journalistic answers. One is, I'm curious to know our thoughts on the different vaccine options. You may want not to take that unless you have very good insurance from your lawyer.
My advice to anybody who can get it is take the mRNA vaccines. I was a skeptic early on. It turns out that it doesn't work for all diseases, but this one it's fantastic for. And there's a reason for that. The target of these vaccines is the receptor binding domain of the spike protein. And it happens to do something that most viruses don't do. And that is, I call it like magical origami. You make like a sheet of paper and you kind of touch it and it folds up into a phoenix origami. This thing loves to fold up just exactly right. It doesn't need what are called disulfhydryl bonds or anything. It just folds up. And it's the right technique, the right technology for the right disease. It is fantastic. And we can vary that in one way or another and we can do it quickly. You can make huge amounts of it very quickly. You can adapt and change it very quickly. It's a fantastic technology. The other technologies aren't as good, frankly. So the technologies that will eventually, just like a virus, outcompete everything else is this mRNA technology. And I can tell you there are people all over the world rushing to do their own versions of these mRNA technologies, and they will be successful.
Yeah. So I'm gonna answer that. Someone earlier asked if we should alter our protocols that we've been following, our public health protocols that we've been following, as former FDA Commissioner Scott Gottlieb recommended. My answer is going to be no, and we're just going to move on from there because Dr. Haseltine just described why no. The other question is, do you think that the quarantine rule in Canada, 14-day quarantine for anyone coming in, could be safely discarded if we have a negative PCR test?
Because what the Chinese have discovered is that the nasopharynx PCR test is not sufficient. Actually, they do something very clever. They give you an IgM test. You can't come into China with an IgM test that's positive. And what does an IgM test do? The first antibodies you make are called IgM antibodies. And they rise and fall in about a 5 to 7 week period. If you've been infected and you have no IgM, you've been not infected for 7 or 8 weeks. They know that a small fraction of us, maybe 5% of us, shed virus for more than 2 weeks. That's why they do anal and fecal swabs. That's why they do it. And that's why they can stay pretty much clear of the virus. So a 2-week period is not actually sufficient. What is sufficient is an IgM negative test followed by a 2-week quarantine combined with an anal swab or a fecal test. That's what you actually have to do if you really want to stay clear. Are we going to do it in the United States? I doubt it.
Next question, Jennifer Arnold, one of our diver members and explorers, asks, she's driving to Maldives through Qatar airline, which requires a PCR test too. She'll wear a shield, and she's vaccinated with Pfizer. Is there anything else that she can do to stay safe? My answer would be bring a tank with you and breathe through your regulator.
And don't eat while you're on the plane, and be very careful of who's cleaning your room. There's millions of things you have to do, especially in places where people congregate from all over the world. It's I personally am not planning to travel for a while, even though I'm vaccinated. I just don't trust what the variants can do, and I don't trust my fellow humans to have behaved properly.
One other, this actually, I absolutely have zero idea because I don't remember. One other question asks, I understood that Moderna and Pfizer were based on previous SARS vaccine methods, and that was one reason these were developed so quickly. Is this true? Thoughts on this?
It is true that the Gates Foundation and others at NIH had recognized the potential of the mRNA vaccines. And in fact, had been deploying them for things like Ebola and a number of other, I think, as I mentioned earlier, there are like 8 different vaccines that had been done before. So the technology was there. And the recognition that this was a technology that could be rapidly ramped up. And I have to say that, as I mentioned earlier, I was somewhat skeptical that it would work. I have to say I'm totally delighted. It's worked much better than anybody thought. And there's probably some interesting reasons. Not only does the antigen fold properly, but when it goes into your body, it isn't just produced once. It probably is produced for a long time. And actually, I've seen studies now where they actually measure the amount of protein in your blood after the first inoculation. And it's there until your antibodies come up and clear it. Then it's pretty clear. You get your second shot, you see the protein come up again and then slowly disappear. But it lasts probably 10 days before your antibodies get it. So you're getting vaccinated and vaccinated and vaccinated and vaccinated. You're really educating your immune system by sticking the RNA in, not just sticking a protein in which shoot up. You're putting an RNA into a cell, and that cell is cranking out protein for a long time until your body says, okay, I've seen it, I want to get rid of you. But then you give it another bolus. So that's one of the more interesting things about this vaccine. I think many people didn't understand until they actually saw that experiment done. And it's been done now. You actually see the protein come up, stay for a long time. You make antibodies, comes down. You give it another shot, protein goes up, stays for a while, goes down. And it's that length of time, I think, that gives you about 10 times the protection you get from a natural infection. And the virus isn't there to mess up your immune system. The virus actually meddles a lot with what it doesn't want. It doesn't want to be seen, so it can hide. But it doesn't hide, doesn't have all those tools to hide from this kind of vaccine.
Another question addresses what, potentially vulnerable position for China, and especially with regard to I don't know if this is correct, but no external infection. So they may think that vaccination may not be necessary, and therefore find themselves vulnerable. But perhaps I could tack another question to this based on really the geopolitics of vaccination that we're dealing with now, which I know you as a member of the Council on Foreign Relations are very sensitive to. You know, India is the largest producer of vaccine. Please correct me if I'm wrong. And now they're shifting their resources to their internal crisis rather than producing vaccine for other countries. So perhaps you can explain, you can expand a little on the geopolitics of vaccination and the bioethics of it too. I mean, really, this is the point where bioethics and geopolitics are coming together, and geopolitics is definitely, and self-interest are definitely going to win the day.
Well, you know, the first answer I've given, I recognize is somewhat unpopular, is that you can't imagine a country that can make its own vaccines, shipping huge amounts of vaccines at the expense of its own population. That's just not human nature. Fortunately, we're right at an inflection point right now where the manufacturing capabilities to make these mRNA vaccines is expanding very rapidly. And very shortly, US will be in a position to export vaccines in very large amounts, billions of doses overseas within the year. I'm convinced of that. And I think we will do that. You know, PEPFAR is a great program. Some people have proposed PEPVAR, which is the president's emergency program for helping to save not just Africa, but the whole world. And I think you'll see that happening. I'm very optimistic that the US will use its enormous resources to share these vaccines around the world. Now, you mentioned that India, which is the largest producer of vaccines, but they don't have the mRNA vaccines. They don't have any of them, unless it's a really exception. I think that will change. But I think there's a lesson here. If you look at the South America, virtually no capacity to make their own vaccines. Africa, very limited capacity to make their own vaccines. So huge parts of the world, Southeast Asia, very limited capacity. Huge population centers, many hundreds of millions of people without the capacity to make their own vaccines. That has to change. And I think it will change. You need your own capacity, as this pandemic shows, to make your own vaccines, whether they're mRNA vaccines or more traditional vaccines. You have to have that capability. And if you're a country like Brazil, like Argentina, many other countries, and you've got to make the vaccines that work, not the ones you think you should make, but the ones that have now been shown to work. For this disease, you've got to make your own mRNA vaccines. China is not going to vaccinate itself effectively with its own vaccine. They've even announced it's not working very well. They better start making their own mRNA vaccines. And my guess is they are. Yeah. As they should do. And
so, and if I can take a point of personal privilege, as my former boss, Senator Kennedy, used to say, this is really the perfect example and a perfect moment to show that profit in healthcare, you know, profit-driven model in healthcare really doesn't work. We really have
to. Let me take a little exception to that. The companies that are making the vaccines are making a ton of money.
Right. No, precisely. But no.
Does that mean that they won't share them? You know, I went through this with AIDS, and it turns out that these profit-driven pharmaceutical companies eventually made their technologies and their drugs available. And you know, the cost in the United States, I remember, was $100,000. It was $100. Take hepatitis B, the drugs that cost $80,000 today. Egypt cured everybody in Egypt. I've written about this for hepatitis C for $35 a person. They tested everybody in the country, everybody over the age 12 and over, and then made it free at a cost of $35. And that is the same time that we in the United States are paying $80,000 for drugs. So companies can pick their market and make their technologies available. I think that's what's going to happen here.
Exactly.
We'll either give it away, or the indigenous manufacturers will make it at a very low cost.
Yeah.
That's true for most vaccines, by the way. Today, India is the greatest producer of vaccines, but they don't make a huge amount of money doing that, because these vaccines are the same vaccine, say a hepatitis vaccine, will cost 20 to 50 times less in India as it costs in the US. So there can be done. It can be both profit, not for profit. And the argument for profit Benjamin Franklin said it, I think, best when he talked about patents. He said, patents add the fuel of self-interest to the fire of invention. And you get a bonfire which is burns super hot, but eventually can help the whole world.
Absolutely. No, I meant to the healthcare system, not the.
Well, the healthcare systems in most of the countries are a mess.
Yes.
That's why my foundation works to try to, the thing you come to realize though, is it's not the technology that's limiting, it's the policies. That health has just been so far down on people's agendas. They think that they decouple the idea that health is wealth. That's the old adage, health is wealth, and it is for a country. And this pandemic makes that so abundantly clear. Let's hope the lessons that we're learning here can translate to health system transformation. That everybody's health is your health. The people who are dying in India right now are not only the poor people. There are a lot of my friends, people who work for me and their families who are dying right now. And they're not poor.
It's always been the case since the Black Death, since the Justinianic plague. All of a sudden, the aristocrats who thought that they were God-given, they had God-given right to rule and be safe, in fact, found themselves in terrible straits and died just right along with everybody else. It's a great equalizer and does put us in a perspective, give us a perspective on on equality and justice. I want to take more of the questions that the audience is asking, but before we do that, I wanted to ask you about you and how you came to follow your curiosity and your genius to become an expert of this science and to write the books that are behind you, if you want to talk about those.
Well, I've written an autobiography that explains some of that. And I would say a couple of things. First of all, I experienced as a very young child seeing my parents suffer from diseases. Very young child. I still remember the feeling of hopelessness to see my mother, who I loved beyond imagination, suffer and be on the brink of death more than once. And I thought, this is not fair. If I can do anything, I'm going to do something. And as a kid, I thought I'd be a doctor, but then I realized that I could probably do more through science to help than I could do as an individual doctor. Not that doctors aren't absolutely necessary, but they need the tools, and I thought I could provide those tools. I'm just now writing another book called Science is a Superpower. And I want young people to realize, if you want a superpower, you want to save the world, become a scientist, become Jonas Salk, become the woman, this unknown woman who invented the mRNA technique that we're using. She's basically just now coming to some recognition. After years of working as a backroom scientist with a belief that this would happen, one person can save the world. It is a real superpower. And it's a wonderful career. So, I've devoted my life to that purpose, but different from many people. I had a purpose, but I picked up different tools to exercise that. The first tool was science, but science including physics and chemistry and even field theory, the most advanced science I could find, and then applied that to medical problems. Then I came to realize all this knowledge gets turned into products. And I created a number of pharmaceutical companies. And I'm pleased to say there are 8 drugs that have been approved by the FDA that have come from organizations that I've created. And then I came to realize that isn't enough. You need a health system. I've seen many examples. I worked with a group called One World Health that created a drug for visceral leishmaniasis in India. But there wasn't a health system that could deliver it to anybody who needed it. So you have to have a system. So the whole thing has to work together. It's not enough to have a solution. That solution has to be affordable and accessible to everyone. And that comes through a confluence of science, pharmaceutical development, and government policy. It's a wonderful triad when it works. And we need to get better at that for all of our health. And that's how I've come to this. Now, it turns out with COVID, every aspect of my career is sort of come together because I know the fundamental science. I know virology. I know pharmaceutical industry. I've developed a bunch of drugs. I've been a consultant to, I think, 20 prime ministers and government leaders, including during HIV to Francois Mitterrand. I was there for about 4 years as a 1 week a month consultant, helping them address those problems. So there's a lot of aspects of my career that have come together, and it's, for me, I'm just feel fortunate that I'm able to add at least some knowledge and some explanation to help people, because one of the things people need to know is what the hell is happening, right? How did this happen? Is it going to happen again? How out of nowhere was I leading my life? You know, we are a species that wants to understand what's controlling our fate. And I think I at least have some understanding through my lifelong experience of what it is that's happened and how we can get ourselves out of this fix. So thanks for the question. It was a very generous question.
No, I always think that that's a question nobody ever asks. And, you know, I know that I came to this discipline and my particularly unique take on it from a very personal experience, not unlike what you just described. So I wanted to explore that for a second. There's one question that I think perhaps is slightly redundant, but I'll take it anyway. When the experts and the person who asks uses quotes. So when some experts said that herd immunity should be reached by allowing the virus to blast through the entire population, that strategy will in fact allow for a more disastrous amount of variance. Is that correct?
Well, I call that simply murderous.
Yeah.
It's mass murder. And I called it out for what I saw. It just the simple numbers. If 1 out of 200 people die and 7 billion people get infected, that's an unacceptable number of hundreds of millions dead. That's just simple math. And when I saw people arguing that, like Scott Atlas, for example, a modified form of that, or the British government, or even the Swedes, I saw it as senseless. The second thing is early on, I think as early as March or April last year, I was saying that there is going to be no such thing as herd immunity. At best, we get the seasonal herd immunity, which means every year we're going to face the same thing. We've got to do much more than that. And thank God we have. I think, you know, the huge investment in warp speed was a godsend. It really was. But most people don't realize, I think, that whole mechanism, all the mechanisms that used were there before for 2 reasons. First of all, HIV/AIDS created all this knowledge and infrastructure, including the architecture of the international vaccine trials. And then the anthrax attack and our bio preparation for warfare and our fear that we would be subject to biological attack created a whole separate series of government mechanisms. BioShield and BARDA were already in place. They were infants, but these infants were inflated with tens of billions of dollars to grow into giants very quickly. But the infrastructure was there. The thought was there. We had gone through, our military and our civilian leadership had gone through exercises, war games. We knew what was going to happen. If you read those war games, they tell you exactly what's going to happen. And we knew what was going to happen, and we used the tools that we had. Thank gosh we had those tools, and that they were being used. Now, some of the tools we had, we didn't use at all to control it. Our social tools, we did use very poorly. But our scientific tools, our manufacturing tools, our pharmaceutical tools, our global network for trials tools, we used brilliant. And that is, again, part of my faith in humanity, that if we don't get everything right, we might get enough right.
Well, thank you so much for this wonderful evening. If you would like to add something, this is the time, but otherwise I would think that...
Well, I just want to thank the Explorers Club for this opportunity. I want to thank you for your very intelligent questions and your own work on this field, which is critical to going forward. And I want to especially thank my daughter, who I've been with for a long time. And it's just been a pleasure. And I want to thank her for offering me this opportunity to speak with you tonight.
Well, thank you, Dr. Haseltine, and thank you, Mara Haseltine. I have a few announcements before we close. This is the lineup of events for the week. Tomorrow, Tuesday, we will have Women of the Deep. On Wednesday, we'll have the Explorers 50 with youth empowerment. On Thursday, Chapter Connect with Texas. And Monday, we'll have a really exciting program with the world-renowned bird expert David Sibley and the cicada, sorry, my European accent is kicking in. It's past bedtime, I guess. And the cicada specialist John Cooley and special host David Rothenberg, all brought to you by the Lectures and Programs Committee chaired by Ann Passer. Have a wonderful evening, and thank you for joining us at the Explorers Club.
Thank you.